Ask Claude anything and it answers. Ask it to open one file on your laptop and it simply can't. This is Learn MCP from the NBX Studio. By the end of this chapter, you'll know what Claude actually is, what it genuinely cannot touch on its own, and which single part of a Claude call MCP goes on to fill. No MCP code, yet just the shape of the thing, so that nothing later feels like magic. Let's start with the thing nobody says out loud. Claude is not a program sitting on your computer. It runs on Anthropic's machines, and you talk to it over the internet. You send text, it sends text back, and that is the entire relationship, which means that on its own, it cannot open your files. It cannot read your database. It cannot see your calendar or post a message in your Slack. And none of that is a permission you forgot to switch on. There is simply no way for it to reach across that line. So, how does any AI app you have ever used actually do anything? Your code does it. Claude replies in ordinary text saying what it wants, and your code, which lives on your side of the line, goes and does the work, then hands the result back. Your files, your database, your calendar, all reachable now, but only ever through you. That is the whole trick, and every tool, every integration, every agent you have used works exactly this way. And MCP, the entire subject of this course, is nothing more than an agreed way of describing what sits on your side of that line so that Claude can ask for it by name. So here is how you send that text. It is one function call, and this is all of it. You import the client and create it, and it quietly reads your key out of an environment variable, which is why you never see the key in the code. Then messages.create sends the conversation and waits. That single call is the entire API. Everything else you'll ever write is arguments to it. Model picks, which Claude answers, and Sonnet is the fast, affordable one. Max tokens is a ceiling on the reply, not a target, so a high ceiling costs nothing by itself. And messages is the conversation so far, where every entry carries a role, either user or assistant. The reply comes back as a list of content blocks, which is why you index into it rather than printing the message directly. Here's the part that trips people up, and this one matters enormously later. The API is stateless. Claude doesn't remember your last message. There's no session on their side holding your conversation. So when you want a second turn, you send the whole thing again. Your first message, Claude's reply, and your new question, all in one list. That's why the messages list keeps growing, and why a long chat costs more than a short one. You're resending the entire history on every single call. 3 messages here, and all 3 go over the wire. Hold on to that, because in a few chapters you'll watch a loop append tool results to this exact list. Quick check before we go on. To run that file, what do you actually need? Just Python, because Claude is built in, or the Anthropic package and an API key. Have a think, and pause the video if you would like a moment. Ready? You need the package and a key. There's no model on your machine. That call goes over the internet to Anthropic servers, and the key is how they know it's you. One more argument, and it's the reason this whole course exists. Alongside messages, the call takes tools, a list describing functions Claude is allowed to ask for. Each one is a name, a description Claude reads to decide when it's useful, and a schema saying what arguments it takes. Claude never runs those functions. Claude just replies saying which one it wants and with what inputs, and your code does the running. So the question the rest of this course answers is simply, where does that list come from? Writing it by hand for GitHub, for Slack, for your database, forever is the problem. MCP is the answer, and now you know exactly which argument MCP is filling. For things to install, and then we'll never do setup again. First, Python 3.10 or newer, because the MCP SDK needs the newer typing features. Second, UV, which is a Python package manager that's dramatically faster than pip and is what the MCP docs assume you're using. Third, the SDK itself. Note the square brackets around CLI. That pulls in the command line tools as well as the library, and you'll want them. And fourth, your key, exported in the shell so the client can find it. Python, UV, the SDK, and a key. That's the whole list. 3 things to carry forward. Claude runs on Anthropic's machines and cannot reach anything on yours. Your code is the only thing standing on both sides of that line. And the call that talks to it takes a model, a ceiling, the conversation, and a list of tools, which is the argument MCP exists to fill. Not using Claude? The same ideas hold. Every major model has an equivalent call, and MCP itself is model agnostic. Next chapter, what MCP actually is and why it exists at all. You want Claude to reach your GitHub, your Slack, your database. That plumbing is weeks of work. This chapter is about why you mostly don't have to write it. You'll leave knowing what an MCP server and client actually are and the 4 messages that pass between them. Learn MCP on the NBX Studio. Forget the jargon for a second and picture a food delivery app. You could partner with every restaurant one at a time, negotiate each menu, handle each payment, arrange each driver. That works, and it's your whole life. Or you plug into a platform that already did all of that, and you get every restaurant at once. MCP is the second one for AI tools. Somebody has already written the GitHub connection, the Slack connection, the Postgres connection, and packaged each as a thing you plug into. That package is called an MCP server, and the part of your app that plugs in is called an MCP client. Those 2 words are the whole vocabulary. It's worth seeing why anyone bothered inventing a protocol, because the answer is a multiplication. Say 4 different apps want tool access: your editor, a chat client, an IDE, a terminal agent, and 4 services worth reaching: GitHub, Slack, Postgres, the file system. Without a standard, every app writes its own version of every connection, so watch what that actually costs. 16 separate integrations, and not one of them is shareable with anybody else. With a standard, it's 4 servers and 4 clients, 8 pieces instead of 16, and the gap widens fast as either side grows. That's the entire economic argument for MCP, and it's why the shape caught on as quickly as it did. So, concretely, here's the shape. Your app opens a connection to a server, and the first thing your app asks is, what can you do? The server answers with a list of tools, each carrying a name and a description. Then when you want one of those tools run, your app calls it by name with arguments, and the server runs the function and hands back the result. That's the entire protocol at this level: a question, a list, a call, a result, which means everything else in this course hangs off those 4 messages. Everything else in this course is detail, hanging off those 4 messages. One thing happens before any of that, and it explains a lot of confusing behavior later. Initialize is the handshake, and it's where both sides declare what they can do. Your client says which optional features it supports, whether it can handle elicitation, for example. The server answers with what it offers: tools, resources, prompts. And the rule that falls out is simple: a server must not send a request the client never said it could handle. So if you build a server that asks for user input and the client never declared elicitation, you don't get an error at that moment. You get a feature that silently never happens. Which is why, when something mysteriously does nothing, the handshake is the first place to look. Straight from the course. Your app wants to read GitHub repositories. With MCP, who writes the GitHub integration? You do, from scratch. Or the MCP server author already did. Have a think, and pause the video if you like a moment. Ready? The server author already did. That's the entire point. You install their server and connect to it the same way you'd install a library rather than rewriting it. 3 lines to keep. An MCP server is somebody else's integration, packaged. An MCP client is the piece of your app that plugs into a server. And the wire between them carries 4 kinds of message, which we'll meet properly next chapter. Next chapter is the most important idea in MCP, and it fits in one question. Who's in control? Every MCP server exposes 3 kinds of thing, and people mix them up constantly. By the end of this, you'll pick the right one in about 5 seconds, every time, using a single question. Get this chapter, and the rest of the course is downhill. Learn MCP on the NBX Studio. Every MCP server can expose exactly 3 kinds of thing, and they're told apart by who decides when each one runs. A tool is a function Claude chooses to call. Claude reads the description, decides the tool is relevant, and asks for it. The model is in charge. A resource is data your own code fetches, because your app decided it needed context, a dropdown that needs filling, a file the user just opened. Your code is in charge. And a prompt is a workflow the person triggers, typically by typing a / command. The user is in charge. Same server, same decorator style, but 3 different owners, which is why picking the wrong one makes a feature fight you. If the abstract version won't stick, here are the same 3 primitives as a restaurant. The kitchen is your tools. An order arrives and the chef decides what to cook. You don't stand there instructing them, and that's exactly how Claude uses a tool. The menu board is your resources. Your app reads the board to show the customer what's available, and the board doesn't decide anything on its own. And the chef special button is your prompts. Nothing happens until a customer presses it, and then a carefully designed sequence kicks off. The golden rule underneath all of that is one sentence. Ask yourself, who is in control? Here's the test that makes the rule stick. Take one job, show me the release notes, and notice that all three primitives can do it. The code is nearly identical. What changes is who starts it. As a tool, Claude decides. You ask a question, Claude reasons that release notes would help, and calls it unprompted. Good when the model should judge relevance. As a resource, your app decides. The user opens the releases screen, so your code fetches the notes and puts them in context before anyone asks. Good when you already know they're needed. As a prompt, the user decides. They type /release notes, and your pre-written instruction runs. Good when you want the same careful workflow every time. Same data, same server, 3 different owners, and picking the wrong one shows up as a feature that fires when nobody wanted it, or never fires when everybody did. Scenario 1, straight from the course. You're building a document editor, and you want a drop-down listing the available documents, so the user can pick one. Which primitive? A tool, so Claude fetches the list. Or a resource, so your app fetches it. Have a think, and pause if you'd like a moment. Ready? A resource. Your app needs that list to draw its own dropdown, and Claude isn't involved in drawing a dropdown, so your code is the one deciding, which makes it a resource. Scenario 2. A user types /format, report, PDF, and a pre-written instruction tells Claude exactly how to reformat that document. Which primitive? A tool. Or a prompt. Have a think and pause if you'd like. Ready? A prompt. The giveaway is the user typed a command. Nothing ran until a person triggered it, and the instruction was written in advance rather than decided by the model. 3 lines. If Claude decides when it runs, it's a tool. If your code decides, it's a resource. And if the user decides, it's a prompt. 1 question, asked every time. Next chapter we stop talking and build a server, and you'll see it's shorter than you expect. Building an MCP server sounds like a weekend project. It's about 20 lines. In the next few minutes, you'll build a working server that Claude can genuinely call, and you'll understand every line, including the one everybody asks about. Learn MCP on the NBX Studio. For steps, and step 1 is boilerplate you copy once and forget. MCP server with a name gives you a server object. That's genuinely it, because MCP server does the protocol work for you. The server exists now. Step 2 is your data, and here it's an ordinary Python dictionary because nothing about MCP requires a database. Step 3 is the interesting one. The @mcp.tool decorator registers the function below it, and the name you give is the name Claude will call, while the description is the sentence Claude reads when deciding whether this tool is the right one. Then the function itself is completely ordinary Python, a lookup, an error if the note's missing, and a return. No MCP anywhere inside the body. And step 4 runs it. 1 line at the bottom, and we'll come back to what STUDIO means in chapter 10. Now the piece everybody asks about. What is field actually doing there? It isn't validating anything, and it isn't creating a database column. Field with a description attaches a human sentence to that parameter, and MCP turns your whole function into a JSON schema that gets handed to Claude. The tool name goes in, the tool description goes in, and each parameter goes in with its own description. Strip the field out, and Claude still sees a parameter called note_ID, but with no idea what belongs there, so it guesses, and guessing is where bad tool calls come from. It's a label for the AI, and nothing more. From the course. What does field with the description actually do? It validates user input. Or, it gives Claude a hint about the parameter. Have a think, and pause if you'd like a moment. Ready? It's a hint for Claude. Agentic can validate types elsewhere, but that description exists purely, so the model understands what to put in the slot. Let's actually run the server, because a server that only exists in a file isn't a server yet. The MCP command line tools ship with an inspector, and pointing it at your file starts the server and opens a panel where you can poke at it by hand. Ask it to list the tools and you get back exactly what Claude would get. 1 tool, its description, and the schema for its argument. And calling the tool by hand returns the note text, which is the same value Claude would receive. 1 tool registered, 1 parameter described, and a real result coming back. That's a working MCP server, and nothing has touched Claude yet. The pattern to remember in 3 lines. The decorator registers it. The function underneath is ordinary Python. and field describes the parameter, so the model knows what to put there. You've got a server. Next chapter is the other half, the client, and the loop that makes Claude actually use it. Here's what confuses everyone at first. Claude can't run your tool. Your own code does. Once you see the loop that makes that work, the whole protocol clicks, and you'll be able to write the client half yourself. Learn MCP on the NBX Studio. The connection boilerplate never changes between projects, so you write it once and copy it forever. What matters is that there are only 5 methods you ever need. List tools asks what can you do, and back comes every tool with its description. Call tool runs one by name, and back comes whatever the function returned. Read resource fetches data your app wants. List prompts and get prompt handle the user-triggered workflows we met in Chapter 3. 5 methods. That's the entire client surface, and because the connection code around them never changes, there's nothing they're worth memorizing. Now the part that makes MCP feel alive. Your app runs a loop, and here's one lap of that loop. Your app loops, and you send Claude the user's question together with the tools from the server. Claude replies asking for read note with an argument, asking, not doing, and that distinction is the whole reason your app exists. Then comes the check that ends everything, and we'll come back to that line in a moment. Your code calls the tool through the client, which is the only place in this entire system where anything actually executes. Then you append the result to the messages list and send the whole conversation back to Claude, and round you go again. The loop ends when a reply carries no tool request at all, because at that point Claude is answering the person rather than asking your code for something. Let's watch a real question go round, because one lap never shows you the point. The user asks, "What's on my to-do list?" and add milk to it. That needs 2 tools, so it needs 2 laps. Lap 1, Claude asks to read the note, your code runs read note, and the text comes back. You append that result and send everything back, which means Claude now knows what's on the list. Lap 2, Claude asks for edit note with milk appended, because Claude can only decide the second step once it has seen the first result. And on lap 3, there's no tool request at all, just the sentence for the user, so the loop exits. 2 tool calls, 3 trips to Claude, and the user typed 1 line. The course asks this one, and it's worth getting right. When does the agentic loop stop? After exactly 3 tool calls. Or when Claude's reply has no more tool requests in it. Have a think, and pause if you'd like a moment. Ready? When there are no more tool requests. There's no counter and no timer. Claude simply stops asking, and a reply with no tool use is Claude talking to the user instead of to your code. 3 lines to carry. There are 5 client methods, and the connection code around them never changes. Claude asks, and your code is what executes. And the loop runs until Claude stops asking. Next chapter. Resources and prompts, and a trick that gets data to Claude before Claude even asks for it. Sometimes your app already knows what Claude is about to need. This chapter is how you hand that over before Claude ever asks, why it's measurably faster than a tool call, and how prompts let you ship your own expertise as a button. Learn MCP on the NBX Studio. A resource is data your own code fetches, and each one is addressed by a URI. Notes://all is a static resource, which always returns the same kind of thing. Here, the list of every file name. The scheme at the front is yours to invent. MCP doesn't care whether you call it notes or files or anything else. Notes:// open brace ID, close brace is the interesting one. That brace segment is a wildcard, and whatever the caller puts there arrives as the ID parameter of your function, which is why the signature underneath takes ID as a string. So one decorator gives you an endpoint for the whole collection, and another gives you an endpoint for any single item without you writing a router. Prompts are the third primitive, and the decorator looks identical again. The difference is entirely about who starts it. A prompt sits there doing nothing until a person triggers it, usually by typing a / command in your interface. What the function returns isn't a string, it's a list of messages, a conversation opener, pre-written by you, that your app drops into the chat on the user's behalf. And because you wrote that opener in advance, you can be far more specific than a user typing in a hurry, which is exactly why prompts exist. They're how you ship your own expertise as a button. Here's the trick the course calls it mentions, and it's the clearest example of why resources exist. The user types @todo MD, then asks, "What's on my list?" Route 1. Your app spots the @mention, calls read resource itself, and pastes the note's contents straight into the prompt before sending it. Claude opens the message, and the note is already there, so Claude answers immediately, one hop. Route 2 is the tool version. Claude reads the question, realizes it needs the note, asks your code for it, waits while you fetch it, and only then answers. 3 hops, and 2 of them are round trips through the model. Same note, same answer, and the difference is that in Route 1 your code already knew what was needed because the user told it by typing that @. From the course. Your app reads the note through a resource and injects it, and Claude responds straight away. Why is that better than a tool? Because tools can't read documents. Or because it's faster. There's no extra round trip. Have a think, and pause if you'd like a moment. Ready? It's faster. Tools can absolutely read documents, so the first option is just wrong. The real difference is that your code already had the data before Claude ever saw the message. 3 lines. A resource is addressed by a URI, and a brace segment becomes a parameter. A prompt returns messages and waits for a person. And injecting a resource beats a tool call whenever your code already knows what's needed. Next is the strangest feature in the protocol, where the server turns round and asks your app to call Claude on its behalf and pay for it. Publish an MCP server that needs a language model, and someone pays for every call. This chapter is about making sure that someone isn't you. You'll see the protocol run backwards and understand the one trick that keeps a public server cheap. Learn MCP on the NBX STUDIO. Picture a public MCP server for research. Somebody asks it to research quantum computing, and the tool scrapes a pile of Wikipedia articles and gathers the raw material. Now the tool needs to turn that pile into a readable report, and summarizing needs a language model. So the obvious move is to put your own Anthropic key on the server and call Claude right there. That works perfectly on day 1, when the only user is you. But every user's request flows through your code, which means every single summarization is billed to your key. Your server gets popular, and the bill arrives with the popularity. That's the corner sampling exists to get you out of. Sampling flips the direction. Normally, the client asks the server to do things, and every arrow points one way. Here the server turns round mid-tool and asks the client, "You call the model for me and send me back what it says." The tool takes a CTX argument, which is the server's line back to whoever connected. The call that does the asking is ctx.session.createMessage, and the key detail is that the client is the one holding an API key, so the client is the one who pays. The course calls it reverse Uno, and the restaurant version is nicer. We prepped your ingredients, but would you cook the last step at your house? You've got a kitchen and your own gas bill. The generated text comes back as the result, so your server stays cheap to run no matter how popular it gets, because the expensive part never happens on your machine. For that to work, the client has to agree in advance, and agreeing is one function. You write a sampling callback, and the SDK calls that function automatically whenever a server asks for a generation. Inside it, the messages the server sent arrive as prums, messages, in MCP's own format, so you may need to convert them into whatever shape your model expects. Then you call Anthropic yourself. This is your code, your key, your bill. And you register the callback when you open the session, which is the moment you're consenting to the whole arrangement. Nothing happens without that callback, so a client that never registers one simply can't be asked. Now, the part the course you may have read doesn't cover, because the spec moved. As of protocol version 2026-07-28, sampling is deprecated. It has not been removed. It stays in the specification for at least 12 months, and every existing client and server that uses it keeps working. But the official guidance is blunt. New implementations should not adopt it, and existing ones should migrate to calling an LLM provider's API directly. The earliest it becomes eligible for removal is a revision released on or after July 2027. So, why did we just spend a chapter on it? Because sampling is the clearest window into how this protocol thinks, a server that needs intelligence but refuses to hold a key, and because the code you inherit this year will be full of it. Learn it, recognize it, and don't start something new on it. The course asks it directly. In sampling, who pays for the Claude API call? The MCP server author. Or the client, whoever connected to the server. Have a think, and pause if you'd like a moment. Ready? The client pays because the client is the one that actually makes the call with its own key. That's the entire reason sampling exists rather than being a curiosity. 3 lines. Sampling reverses the protocol. The server asks the client. The client holds the key, so the client pays. And it takes one callback on the client and one CTX call on the server. Next chapter. How you stop a server reading files it was never meant to touch. You're about to let a server touch your file system. This is what MCP actually gives you for controlling that, and more importantly, what it doesn't, because the guarantee most people assume here does not exist. Learn MCP on the NBX Studio. The client decides which folders are allowed, and usually those paths come straight from the user as command line arguments when the app launches, for instance. Each path gets wrapped in a root object with a file ://URI because the MCP spec requires that exact format rather than a bare path. So movies is allowed and desktop is allowed. Then you write a callback that returns the list, and you register that callback when you open the session. The subtle part is that the server never receives the roots up front. The server asks for them on demand and your callback answers, which means the client stays in control of the list the whole time. Here's the part that surprises people, and it's the most important sentence in this chapter. Is path allowed is not part of the MCP library. You write it. The SDK gives you CTX, session to list roots, which fires the client's callback and returns the allowed folders. That much is genuinely MCP's. Comparing a requested path against that list is entirely your responsibility. The trick is relative to, which raises a value error when the path isn't inside the folder. So a successful call means it's a child, and an exception means it isn't. Movie/clipped MOV sits inside a granted root, so that one's allowed. And if nothing matched by the end, you return false, which is how /etc/password gets refused. Leave this function out, and every tool you write can read anything the process can read. 2 corrections before you build anything on this, and the first one matters more than the deprecation. Roots is not access control. The specification says so directly. Roots are informational guidance, and the protocol does not enforce that servers stay within them. A keycard that the hotel never checks is not a keycard, which is exactly why you write that path check yourself, and why leaving it out isn't a missing feature, it's an open door. Second, Roots is deprecated as of the same 2026 revision, alongside sampling. The migration is to pass the directories you care about as ordinary tool parameters, or as resource URIs, or in the server's own configuration, all of which are explicit, visible, and don't pretend to be a security boundary. True or false, straight from the course. The MCP SDK automatically stops tools reading files outside the roots. True, MCP enforces it. Or false, you write as path allowed yourself. Have a think and pause if you'd like a moment. Ready? False. MCP hands you the list and nothing more. The enforcement is code you write, and if you skip it there is no error and no warning, just a server that reads whatever it likes. 3 lines. The client declares the roots as file URIs. The server asks for them on demand, through list roots. And the check against them is yours to write every time. Next, how a long-running tool tells the user it hasn't frozen. A tool that runs for 30 seconds and says, nothing looks broken. 2 calls fix that, 1 more lets the person stop it, and by the end you'll know which of them the spec has already deprecated. Learn MCP on the NBX Studio. On the server side, there are exactly 2 calls worth knowing, and they do different jobs. CTX info sends a log line, a human sentence about what's happening right now. Searching Wikipedia, for instance. CTX.reportProgress sends a number instead. How far through? Out of how much? 30 out of 100. As the work moves on, you send more of both, writing report and 80%. Neither call changes what the tool returns, because they're side channels that travel while the tool is still running, which is exactly why they're useful. On the client side, you'll write 2 callbacks, and where each one's registered is the detail people get wrong. The logging callback goes on the session because log messages can arrive from anything the server's doing, not just the tool you happen to be waiting on. The progress callback goes on the individual call tool because progress belongs to one specific piece of work, 30% of what otherwise? Register them both and your interface can show a spinner with real text and a bar with a real number, instead of a frozen window and a user reaching for the close button. Progress solves half the problem. Here's the other half, and the spec lists it as a core utility alongside progress, cancellation. If a request can run for 30 seconds, the person watching needs a way to stop it. Otherwise, your only honest option is making them wait for something they no longer want. When the client cancels, your tool's async task is canceled underneath you, so the shape that saves you is an ordinary try. And finally, Clean up whatever you opened, then let the cancellation propagate. Swallowing it is the mistake. Catch and ignore, and you've built a tool nobody can stop. And if the work is genuinely long, minutes rather than seconds, that's what the task's extension is for. It hands back a durable handle you pull, instead of holding a request open and hoping. One caveat, and it splits this chapter in two. Progress reporting is current, healthy, and listed in the spec as a core utility. Report progress is not going anywhere. The logging half is deprecated, in the same 2026 revision as sampling and roots. If you're on STUDIO, the guidance is to write to standard error instead, which the client already captures. And for anything you'd actually operate in production, use OpenTelemetry, which is built for exactly this and gives you traces rather than loose strings. So keep report progress and treat CTX info as something you'll meet in existing code rather than something to build on. 3 lines. The server sends CTX info for words and report progress for numbers. The logging callbacks registered on the session, and the progress callbacks registered on the individual call. Next chapter's got a trap in it. 2 flags that quietly switch this entire feature off. Your server works on your laptop. Putting it on the internet takes 1 word. It also takes 2 settings that quietly switch features off if you don't know what they do, and you'll leave knowing exactly which features and where those settings actually live. Learn MCP on the NBX STUDIO. There are 2 transports worth knowing, and they carry exactly the same JSON. STUDIO means the client launches the server as a child process on the same machine, and they talk over standard input and standard output, like 2 people at one desk passing notes. Every feature works, setup is nothing, and it only ever works locally. Streamable HTTP means the server runs somewhere else entirely, and you reach it over the network, which is what you need the moment the server isn't on the user's laptop. That's the whole choice. STUDIO while you're developing, HTTP when you ship. STUDIO deserves a closer look because how it works explains a bug almost everyone hits once. The client doesn't connect to a running server. The client launches the server as a child process and then talks to it down that process's own standard input and standard output. So standard out isn't where your program prints, it is the wire, which means a stray print left in from debugging writes a line of plain text into the middle of a JSON RPC stream, and the client fails to parse it. The error you get points at JSON, not at the print statement that caused it, which is why this one costs people an afternoon. Print to standard error instead, the client leaves that alone, and you'll see it in your terminal. And now the logging deprecation from the last chapter makes sense. Standard error is exactly where the spec is telling you to send logs. Now the trap, and it's worth reading twice. First, where these flags actually live, because this catches anyone who learned MCP a year ago. They are not constructor arguments. You pass them to run, alongside the transport, and the server object itself knows nothing about them. Stateless HTTP true means the server forgets each client between requests, which is exactly what you want behind a load balancer, because any instance can then answer any request. The cost is severe, though. Sampling stops working, elicitation stops working, roots stop working, and subscriptions stop working. Every one of those needs the server to remember who you are between calls. JSON response true means replies come back as plain JSON instead of a stream, which kills live progress and log messages, since streaming is the mechanism those travel on. Notice what survives both. Ordinary tool calls. So start with both false, which is the default, and only reach for either when you genuinely need horizontal scaling and can say out loud what you're giving up. 3 lines. STUDIO is for development on one machine. Streamable HTTP is for production across the network. And both flags default to false for a reason, turning either on trades features for scale. 1 chapter left, and it's the one where we put the whole protocol back together. Halfway through a tool, you need something only the person can give you. Maybe a choice, maybe an API key, and those two are not the same because one of them the spec forbids you asking for in chat. This chapter is how you ask for both, properly. Learn MCP on the NBX STUDIO. Form mode is the ordinary case. Your tool stops, describes what it needs, and hands over a schema. CTX, elicit takes a message the person will read, and a pedantic model describing the shape of the answer, so the client can render a real form with a labeled field instead of guessing from prose. The schema is deliberately restricted to flat, primitive fields, strings, numbers, booleans, enums, because every client has to be able to draw that form, and nobody draws an arbitrary nested object well. A string field with a title and a description becomes a labeled text input. An enum becomes a picker, which means the person can't mistype the answer. And what elicit returns carries an action, which is the field people forget to check. Now the important one, and it's a rule rather than a preference. The specification says servers must not use form mode to ask for passwords, API keys, access tokens, or payment details. Must not, because anything typed into a form travels back through the client and through whatever happens to be logging there. So for those, you use URL mode. Your tool hands back a link, the person opens it in a real browser, and the secret goes straight from them to you without ever crossing the client or the model's context. CTX, elicit URL, takes the message, the URL, and an ID you'll use to track that particular handoff. There's a subtlety here that causes real bugs. What the client sends back only says the person consented to open the link, not that they finished whatever was on the other side. The interaction happens out of band, so the client genuinely doesn't know how it went, which is exactly why you passed an ID. Your server tracks that handoff itself and decides when it's done. When it is done, you tell the client with send elicit complete, and the original call can carry on. This same shape is how third-party OAuth works in MCP. Your server acts as an OAuth client to Stripe or GitHub, and the tokens it receives never touch the MCP client at all. The spec requires that, because a server passing someone else's token back through the client is a security hole with a name, token pass-through. Every elicitation can end three ways, and treating the result as a Boolean is the bug people ship. Accept means the person filled the form in and submitted, and only then does result.data hold anything at all. Decline means they explicitly said no, they read the request and refused. And cancel means they dismissed it, closed the dialog, pressed escape, clicked away. Those last two are genuinely different, and the difference changes what your tool should do next. A decline is an answer, so offering an alternative is reasonable. A cancel isn't an answer at all, so asking again later is reasonable. Handle all three explicitly, because a tool that reads a dismiss dialog as a refusal will quietly stop offering something the person actually wanted. 1. To check you've got the rule. Your tool needs the user's Stripe secret key. Which mode? Form mode, with a string field marked secret, or URL mode, sending them to a page you host. Have a think and pause if you'd like a moment. Ready? URL mode, and it isn't a style choice. The spec says servers must not request credentials through form mode because that data passes through the client on its way back to you. 3 lines. Form mode asks in the room, against a flat schema. URL mode sends them out of the room and is mandatory for anything secret. And every answer is accept, decline, or cancel. 3, never 2. 1 chapter left, where we put the whole protocol back together and sort what's current from what's on its way out.
You've got all the pieces now.
This is where they fit together into one mental model you can carry into real code, plus an honest list of what the specification has already deprecated, so you don't build on the wrong thing. Learn MCP on the NBX STUDIO. Here's the whole thing on one screen. Tools are functions the model chooses, and Claude never runs them. Your code does in the loop. Resources are data your code fetches, and injecting one beats a tool call whenever you already know what's needed. Prompts are workflows a person triggers, which is how you ship your own expertise as a button. Sampling reverses the protocol so the client's key pays, which is what makes a public server affordable. Routes are file access control that the SDK hands you, but never enforces. And notifications are how a slow tool proves it's alive. Underneath all 6, one question keeps working. Who is in control? And for sampling, who is paying? Before you go and build, here's the state of play because a lot of MCP writing online predates it. Tools, resources, and prompts are current, and they're the spine of everything. Elicitation is current, and it's where the protocol is putting its weight now. Sampling is deprecated as of the 2026 revision. Migrate to calling a provider API directly. Routes is deprecated too. Pass paths as tool parameters, resource URIs, or server config instead. And logging is deprecated. Standard error on STUDIO. Open telemetry in production. None of those 3 vanish tomorrow. They stay in the spec for at least 12 months, and the code you inherit will be full of them, which is exactly why you learned them. Just don't start something new on a feature the specification has already told you it's retiring. The final question, straight from the course. You're building a public MCP server for a weather service. Users connect from their own apps, and the server needs a language model to write the forecast in plain English. What's the smartest approach? Put your Anthropic key on the server and call Claude directly. Or use sampling, so each client calls Claude with its own key. Have a think, and pause if you'd like a moment. Ready?
Sampling.
Option 1 works beautifully until the day somebody shares your server, and then every forecast in the world is billed to you, which is precisely the corner sampling was invented to avoid. For things to go and do, in this order, build the notes server from Chapter 4. Add a resource and read it from a client. Add a tool that reports progress, and watch the callback fire. And make the server ask you to call Claude, which is sampling, and the moment it clicks. 3 lines for the whole protocol. Ask who is in control, and the primitive names itself. Claude asks, and your code executes, always. And check the spec status before you build, because 3 of the features you just learned are already on their way out. That's the course. You've got the mental model now, and the syntax is a search away. The interactive version is linked below if you'd like to step through it yourself.
Go and build something.